Hi guys. This video is on the simulation of second-order differential equation using Simulink. The video is brought to you by brilliant minds. Please like and subscribe the video and channel. Hope you find it useful. Please feel free to write any suggestions, doubts in the comment box. So, you must have MATLAB installed on your system. If you don't have a license, you could use institutional login if your institute provides the same. Or else you could do online version of Simulink. Simulink is a MATLAB-based graphical programming environment for modeling, simulating and analyzing multi-domain dynamical systems. Its advantage is that it uses graphical blocks rather than coding. Consider the second-order differential equation as shown. First we have to rearrange the equation such that the highest order term with coefficient is 1 on the LHS and all other terms to the RHS. Now, you are ready to go. Open MATLAB and then open Simulink. Wait for it to load. Now open the library browser. It has all the Simulink blocks arranged into different categories. What we are doing is that we will be using a MATLAB function block where we write the rearranged second-order equation. That's the first step from Simulink block. Go to Simulink on the left pane and then user-defined functions and select MATLAB function. Drag and drop to the workspace. The input is represented as U and output as Y, as you can see from closer look of the block. Double-click the function to open it. Here you can write your code. The input to the function is U and output is Y by default. But you can add as many number of inputs, outputs and their transformation in the function block. Note the function name. You could change it according to your wish. Here we have only single output Y, which is the RHS of the rearranged second-order equation. Note that this block gives the second-order term as output. We need two inputs, as we can infer from the RHS of the rearranged equation. One is the first derivative of Y and the second is the term Y itself. Please don't get confused the Y's. In the equation we have used Y as the variable, and in the MATLAB function block is also represented as Y, but both are not the same. The function block's output is actually second derivative of variable Y but is notated as Y. You could change it to some other variable. The two inputs are represented here as U1 and U2. U1 represents first derivative of Y and U2 represents the variable Y. If you feel it confusing, you could change it to some other variables. Now fill the function according to the rearranged equation. Compare and you could understand it. Okay, that seems to be confusing, so we can change the notations accordingly. YD dot represents second derivative of Y, YDOT, the first derivative of Y and Y, the usual Y. NPW we need to get YDOT, that is second derivative of Y and Y itself. What is there with us is YD dot, which is the second derivative of Y. So we use two integrator to obtain YDOT and Y by serial arrangement. It's a dynamical equation, so it is not working with an input producing an output. It's a feedback system, so we need to give initial conditions to both the integrator S. It can be set to 0 or according to your wish and see the changes in output. The integrator is located at common, Y used blocks and then integrator. It is represented as 1 per second, the Laplace transform form. Drag and drop to the workspace and arrange. Connect with the block by clicking at output of MATLAB function block and dragging to obtain the signal line to input of integrator and connect the other integrator similarly. You may name the signal lines to get a better understanding. Now we need to see the outputs. We need what is known as the scope. You can obtain it from the library or in a more easy way by double-clicking the workspace and typing scope. Double-click and you can see the scope. We can change the inputs by right-clicking and selecting signals and ports. Here we just viewing only the output, so we need only one. We can later change the inputs to scope. Now complete the diagram. Then set the initial conditions of both integrator s to 0 by double-clicking the integrator and putting 0 in the initial conditions block. Now the diagram is complete. We can check it by click the Run button. The scope will pop up after the run, or else double-click the scope to view the result. The graph is showing 0 line, since our initial conditions are all 0. So change it and you can see the different graphs. That's all for now, friends. Hope you enjoyed it. Please like and subscribe, and you could put your valuable feedback in the comment box. Thanks for your time.